So what I'm going to do to set up temporary access, I'm going to click on My Lab and Mastering Course Home. Again, I'm hoping the student mode will carry over to Pearson. I think it does. So I click on that link. I'm going to accept the terms and conditions. And if I haven't had a Pearson account before, I'm going to create one. I'm going to say let's see. Do my password. We're going to assume Bart's grown up. Create the account. Let's see, there should be. So it doesn't seem to. Oh, down here. If you click down here, get temporary access without payment for 14 days. This link here. So click on that. And so what that's going to do, it's going to give you 2 weeks to kind of figure out what you're going to do. And then go to the course. Now, because we did this through Blackboard, you don't actually need the course ID that's included. So you don't have to enter that in. And then there you go. You're in the course. There's the calendar. And there are the assignments. And you're all set. And so that's how you can sign up for the course. Now, again, this is recorded. So if you want to watch it again, it'll be here. It'll be here at the very beginning of the recording. So if you want to review that, or if you want me to send me a message, if you want me to put together something that helps you get through it, or I can just work with you on it. But that will get you into the course. Now, the next thing to do is you want to call Pearson customer service about the access code. Consult Professor Google. So here, I'll put this link in the chat so you can all see. So filling this out. The course is based in the United States. You're going to be a college student. And then the issue is access code. So if the course is based in the United States, it's taught using English, you're a college student, the access code's the issue, and then let's click on product. And what we want is My Lab Math. Just kind of scroll down, there's a bunch of My Labs there. Go down to the My Lab that's math. And then hit I'm not a robot. So bicycles. Does anybody see a bicycle? I see none. All right, I've had this one before. Well, that didn't. Well, then traffic lights. So they're having the text. I talked to students who did the chat session, and they said it was very hit or miss. So you could hit the chat, and you can see what happens. And you tend to get different results depending on who you're chatting with. So now another thing that the customer service person I spoke with today said is you might be redirected to get an alternative access code through the bookstore. Let's try this. I think that's all right. Oh, I gotta be careful because we're broadcasting this technically, so the person on the chat would know. Let me try a different. I know if you select educator, so I'm gonna tell you this, and you decide what you prefer to do. If you choose educator, I'm not gonna advocate this, but they do give you a phone number. The best thing to do probably, in all honesty, is try talking with them on the chat. And if it's not going anywhere, send me a message and then I can call them up on your behalf. And so what would have to happen is if you're trying to get your access code to work and it's not working, and the chat person can't help, what I can do, call me, send me a message on Blackboard, and we'll get a time where you can call me, and it'll be hopefully right away, actually. Don't want to wait too long on this. What we could do is right away, I would need to get your access code that you have for the text, and then I could call Pearson and try to do it on your behalf. I think that would probably be the best thing that we could do. Another possibility is they might be able to let me add you. So there should be, let me try one more time. They might get really upset if you call saying you're an educator, and yeah, don't do that. I wouldn't recommend doing that. So I could call on your behalf. I could do that. So we'll have to look at that. But let me try one last thing. Oh, this looks like a rabbit hole. Let me back up. think we've already been here. I think it's just it's all redirecting to the same web page. So let's just work on getting signed up in the temporary for the temporary registration. And then let me sit down and figure out the best way to get permanent registration. So let's do the temporary one. And then I'll work on how to get the permanent one. Ooh, wait. There's a phone number. Okay, that's educator telephone support. Well, here's the thing. They might be able to redirect you to some kind of a student telephone support, hopefully. So there's that number. You could try that. That's the number for teachers. But if you call that number, they might be able to redirect you to someone who could help a student. And that's what we would want. So it's 877-669-7484. That's 877-669-7484. And again, that's for educators, but they hopefully can redirect you to someone that could help students, or they might just help students. We'll have to find out. But a phone number for students seems to be very difficult to find. So we'll cross that bridge at another time. All right, so let me check one thing. So the major goal for now is try to get that temporary access, just like we went through. For the second part of it, I'm going to go work on that now. Try to figure out how to get this so you can access you can get the permanent registration. So let's see. Okay. All right. So at least you have a way to get into the class. Again, you just click on that link that's under coursework that says the My Math Lab course home. It'll have you register. You accept the terms and conditions, then you'll register. You have an opportunity to put in an access code. Click on that link, that button, and then after that, they'll ask you, how do you want to pay for this? And then you have the, actually, no, I'm sorry, don't click on the access code button. Don't do that. But on the page that has the access code button and the two payment methods, look towards the bottom and you'll see a link that lets you have temporary access. So we'll come back to this. So if you have someone who's not in, if you know someone who's not in the class at the moment, let them know that at the beginning of the lecture, we cover how to get the temporary access. And then I'm going to talk to Pearson and figure out the best way to get the permanent access for everyone. There might be where I can just add you, where I don't have to actually, you wouldn't have to actually technically do much of anything. I can just add you. So I'm going to see if that's an option. But any questions? All right. Well, what we're going to do today, we're in this chapter 1. Now, chapter 1's a review, and it's kind of a fast-paced review. So there's some new things, there's some very familiar things, hopefully. And let's take a look. So we talked about whole numbers and real numbers. We talked about the roster notation for sets, the set builder notation for sets. And set builder notation is just a very formal way of doing things. So if you wanted to say the set of all real numbers, not all real numbers, I'm sorry. The set of positive even numbers, we would write something like this. This is called roster notation. Now, if we're talking set builder notation, we would say something like this. The set of even numbers is any element x such that, again, this is all just kind of formality, such that x is divisible by 2, x is a whole number. Now, whole numbers, those are numbers you count on your fingers, including bring in the number 0 also. So x is one of these numbers you count on your fingers, or 0. And then we say x is divisible by 2. So there we go. Any questions about that? In fact, we don't want to include 0, so we're going to say, let's leave out 0 for now. Let's just go with natural numbers. Natural numbers are the numbers you count on your fingers except 0. And so we want all the even natural numbers. And so the even natural numbers is that x is divisible by 2 and x is a natural number. So what you do is you use this sort of formal introduction. It's all the numbers x such that x is divisible by 2 and x is a natural number. Another way of thinking of this. Let's say we're thinking about all numbers bigger than 3 that are natural numbers. So we can list them out in roster form. Or we can do it in set builder form. All numbers x such that x is natural. It's a number we count on our fingers. And x is greater than 3. So here's the roster method. Here's the set builder method. Now I'll be honest. Looking at the set builder method, it seems worse. Like, this doesn't seem smaller. We want to be efficient in mathematics. We don't want to waste a lot of time and space. Now, the reason this might be better, if we look at a list of numbers, 4, 5, 6, 7, this looks like the pattern we would see if we only want natural numbers bigger than 3. But how do we know that there might not be more to this pattern? Now, the person who writes a roster of numbers, if they're writing it to this extent, if there's any change in the pattern later on, they would let us know, to be honest. But let's say the patterns change so much that you really can't write it all in a list like this. You'd have to make this go on and on forever. So sometimes a description of what you're doing makes more sense. I'll give you an example. Now, who sees the pattern here? 1, 1, 2, 3, 5, 8. What's going on here? Well, what we're doing is creating what's called the Fibonacci sequence. And the way you generate the Fibonacci sequence is you start out with two numbers. It's always 1 and 1. And then you add these two to get this one. Add these two to get this one. Add these two to get this one. And then you would add these two to get 13, the next number in the sequence. So if you're not familiar with this pattern, if you haven't seen it before, then what someone could write would be all the numbers x such that x is in the Fibonacci, I'm going to abbreviate it, sequence. So if you're not familiar with what a Fibonacci sequence looks like, well, we can still talk about the set of all the numbers in the Fibonacci sequence anyway. And we can do that using the set builder notation. Here's another way where it kind of helps. And if I'm going too fast, let me know. Here, I'm going to pull up the chat so I can see. Now, what kind of set of numbers are these? And these are very important numbers. In fact, we use these numbers to help protect nuclear secrets and stuff like this. Very large versions of these numbers, or these large numbers from this set, I should say. Well, this is the set of prime numbers. So in set builder notation, you'd say it's all the numbers x. Remember, x is just an unknown number, such that x is prime. Ooh, now set builder comes out a little bit easier than that. So that's the idea of set builder notation versus roster notation. Any questions about that? So we're going to review inequalities, and you've seen these before. So I'm going to kind of go through fast. So let's take a look at this symbol. As you might remember from elementary school, we say the alligator eats the bigger number. So to show that 2 is less than 3, we write that. Now, if we want to say something is less than or equal to, well, this is certainly true. 2 is less than 3, so it's going to be less than or equal to. You have two options here. But this will also be true. 3 is less than or equal to 3. So for this situation, we have two options, the less than or the equality. Here, the less than turned out to be true. And here, the equals turned out to be true. So you have two options here. Questions about that? Now we have this other symbol. Greater than, and I'm reading this as I go from left to right. So in this case, 3 is greater than 2. We also have this version of it. And once again, 3 is greater than or equal to 2. And it's the greater than part that wins in this case. But likewise, 3 is greater than or equal to 3. And that's the part that wins. So we have less than or less than and equal to. We have greater than or greater than or equal to. So questions about that. Now you want to be kind of careful with negative numbers. These can only kind of throw you off. So if we have our number line, we have positive numbers to the right of 0, negative numbers to the left of 0. Now the way size is judged from left to right. So to the far left is smaller. And as we move to the right, we get bigger. So this means any negative number will be smaller than any positive number. So for example, if I have negative 100 and 2, we would put the less than sign between these. Or if I have 1 and negative 15, I'm going to put the greater than sign like that. So sometimes it's tempting just to look at the actual numbers, but the negatives, they're always going to be smaller than the positives. Another thing to keep an eye on can be a little confusing. Let's take a look at this part of the number line where the negatives are. Let's say we have negative 10, negative 2. Well, which is going to be bigger, negative 10 or negative 2? Well, remember, on the number line, we go smallest from the left to the largest on the right. And since negative 2 is to the right of negative 10, negative 10 is less than negative 2. So any questions about that? So just a little bit about the inequalities. Now, inequalities become interesting in another way when we talk about x. X is less than 2. Now, x could be anything with one condition. X has to be any number that's less than 2. So x can be any number less than 2. So how do we express that? Well, what we do is we draw a number line. And we're going to basically highlight all the numbers that are less than 2. Now remember, smaller numbers will always be to the left. Larger numbers will always be to the right. So we're going to color in everything to the left. And then we're going to put an arrow here to indicate we could keep going to the left. As long as we keep going to the left, that means we're finding more numbers smaller than 2. And what do we do at 2? Well, we want things less than 2. We don't want them equal to 2. So we're going to put a hole. And that says we're not including 2. We just want things less than 2. Now, questions about that? Now, what if we did something a little different? So here's x less than 2. What if I put an equal to on it? Well, I draw my number line. There's my 2. We're talking less than, so everything less than 2. But then we've got this equal to. So that means we can include 2. So I just shade it in like that. If I had something like x greater than 2, well, now I want any number that's bigger than 2. So all the bigger numbers are to the right, and I'll just put an arrow here to say that I can keep going to the right, go on forever. But we're not including 2. It's just bigger than 2. So put a hole, and there we go. Finally, x greater than or equal to 2. Well, all the numbers bigger. It's everything to the right of 2. But then this says to include 2. X can equal 2. It's okay. Put a dot there. Questions about that? Now, in the text, they refer to methods of intervals a little differently. So I'm going to translate over. I'll show you what I mean. Let's say intervals. So let's go back to x greater than 2. Well, the way we write this as an interval is we use a parenthesis and then infinity with a parenthesis. What this is a sort of compact picture of the number line. So we could draw the number line for this. And instead of using a dot, the arrow points off forever. That means infinity. And since instead we're not going to include 2, so we'll put that parenthesis here where the open circle would usually go. So you could put an open circle here, or you can put a parenthesis. So what's going on here? Well, first off, a parenthesis. It means don't include. It's the same as the open circle. It means don't include. So when we don't want to include 2, we use an open parenthesis. And we can place that on the number line instead of the circle. In fact, let me do this, make this a little more consistent. So a parenthesis or an open circle means the same thing. So we're going to go from 2, but not include 2, off to infinity. Now infinity is not actually a number, it's an idea. And you can think of infinity as meaning just keep going. Since we never stop, we never get to have infinity. So we have to not include it also. Not because we're ignoring infinity, it means we never actually get there. It just keeps going forever and ever. So we sort of recognize the fact we can never possess infinity, we can't, by saying that we're not going to try to possess it. So here we're not including 2. Here we can't include infinity even if we want to. It escapes us. Now, let's change things up a bit. Let's say we have x greater than or equal to 2. Well, we write this like so. Now again, infinity's beyond our reach, so we don't even try to hang on to it. That's just a dragon we let fly off into the sunset. But we do get to include 2 in this case. And we use a square bracket to include. So what this would look like on the number line? Well, we still go off to infinity. Then we put in a square bracket that says we get to include 2. And so what this is equivalent to it's the same thing as the closed circle. Questions about that? Now we can mix these up. So let's say I have this. Well, we can look at this at a number. We put this on a number line. We're looking at -2 and we're looking at +3. So -2 is the smallest number, +3 is the biggest number. Now that being the case, x means any number. This is any number between -2 and 3. So we can just shade in everything between -2 and 3. Now, the question is, do we get to keep -2 and do we get to keep 3? Well, since this is an equal, we can think of this as x is greater than or equal to -2, or -2 is less than or equal to x. Well, we get to keep -2. So I'm going to put a bracket. And here we have x is less than 3. We don't get to keep 3. So I put a parenthesis. Questions about that? Now, there's another way of writing this, and we can write it in set builder notation. So these are all numbers x, such that x is between -2 and 3, and we get to include -2. We can write this as an interval, and we can look at the number line to see the interval. We want all the numbers between -2 and 3. We get to keep -2. We don't get to keep +3. So we keep -2, comma, we don't get to keep +3. And we assume that there's numbers going on in between here. So this is sort of a simplification of our number line. Questions about that? Now, we can start with intervals and go to number lines in set builder. So again, if it helps, we can draw this on a number line. Now this interval, again, it's concerned with numbers between -5 and 2. So we'll certainly take all the numbers in between. But do we get to keep -5? Do we get to keep 2? Well, this is a parenthesis, so that means we got to put a parenthesis on -5. We don't get to keep it. This is a bracket. We got to put a bracket on 2. That means we do get to keep it. Finally, we can write this in set builder notation. It's all the numbers x such that, now x is between -5 and 2. So that much we know. The question is, do we get to keep -5? We don't. We got a parenthesis here. So I'm going to use this symbol. But we do get to keep 2. X can be 2. And then that would be our answer using set builder notation. Questions about that? So that's 1.1. Again, it's kind of a long section, a lot to cover there. We're going to talk about negative numbers. We'll probably get through 1.2 today, and then we'll have to move things up a bit, 1.3 and 1.4. So we're looking at negative numbers, and then we'll have some PIMDOFs, and then we'll get into some distributions. So we might just get some negative numbers today. So this is a review of how to do operations with negative numbers. There's addition, subtraction, multiplication, and division. First off, what are negative numbers? They're just the numbers to the left of 0. So if you're positive numbers to the right, negative numbers to the left. Now there's something called absolute value. An absolute value is how far a number is from 0. That's all that it is, how far you are from 0. So if we take a look at 3 and negative 3. Well, negative 3 is 3 units away from 0. 1, 2, 3. And 3 is also 3 units away from 0. 1, 2, 3. Now we represent absolute value by using 2 bars. We put a bar on each side of the number. So the absolute value of negative 3 would look like this. And the absolute value of 3 is going to look like that. Now if that's too small, let me know. I don't want to make these so they're not legible. But because negative 3 is 3 units away from 0, we say the absolute value of negative 3 is just 3, the distance from 0. And then since 3 is 3 units from 0, its absolute value is also 3. So what's going on here? What do absolute values do? They give you distances. In distances, they're always positive. So basically what it does, if something's not already positive, it makes it positive. So when you have a number, the absolute value of a positive number will come out positive. And the absolute value of a negative will also come out positive. So if we take the absolute value of 10, we'll get 10. Take the absolute value of negative 2.5, we'll get positive 2.5. And you can play some games with this. For example, you'll see this sometimes. The negative of the absolute value of negative 3. Well, this right here is just going to be positive 3. So you have the negative still hanging out here. But once we take the absolute value, this becomes that. Now this negative is still here. And so the negative now attaches to the positive 3. We get this. So just be careful of that. That's out there. So any questions? So let's talk more about these negative numbers. I'm just going to give you the patterns on how this works. But let's talk about multiplication. Negative numbers follow a particular pattern. Now, positive times positive is positive. Positive, I'm sorry, let me back up a little bit. So positive and positive is positive. Well, we know that. 2 times 3 is 6. Negative times negative is also positive. Positive times negative is negative, and the negative times positive is also negative. So, for example, 2 times 3 is 6. But negative 2 times negative 3 is also 6. Sort of surprising, but it is. And then 2 times negative 3 is negative 6. And then negative 2 times 3 is going to be negative 6. So there's a pattern to this. When the numbers are both positive or both negative, you get a positive answer. When it's positive negative or negative positive, you'll get a negative answer. Questions about that? Now, division. Division follows the same pattern. Positive divided by positive is positive. Negative divided by negative is also positive. Positive divided by negative is negative. Negative divided by positive is also negative. So when the numbers have the same signs, you're going to get positive answers. When the numbers have different signs, you're going to get negative answers. So that's how you multiply and divide negatives. And it doesn't matter if these numbers are decimals or fractions, it's just whether they're positive or negative. That's what's going to tell us if we're going to have a positive or negative answer. So that's multiplication and division. Now we get to one that can be a little troublesome. Addition and subtraction. Now, before we jump in, there's basically 2 formulas we're going to use, or 2 procedures. But we're going to make one observation before we get into this. Subtraction equals adding a negative. We're going to think of subtraction as the same as adding a negative number. So for example, 5 minus 3, we'll say this is the same as 5 plus negative 3. Subtraction is the same as adding a negative. So we're going to use this so we can add and subtract negative numbers. So that's one thing. Another thing is the double negative rule. So let's keep in mind, subtraction and adding a negative, same things. And then one last bit before we get into our procedures. The double negative. So a double negative equals a positive. So you can think of this like in language. If someone says no ice cream, that means you can't have any ice cream. But if they say no ice cream, well, that means you better have ice cream there. Same thing with this. If we have minus a negative, this becomes positive. Or if we have something like this, we get something like that. Now, one that can sometimes confuse students is this. If I have negative 10, subtract 5. This is not a double negative. This is just a negative number subtracting a positive number. What we mean by double negative is we have minus a negative. That becomes a positive. But there's only one minus here. This is just a sign for the number. But there's only one minus in a row, one minus in a row. So this doesn't change. So I'm just going to kind of circle this as one that sometimes will confuse students. But we got negative and a negative, negative and negative. The parentheses we can ignore. We can ignore that. That becomes a positive. So we have that subtraction is the same as adding a negative. And we have our double negative rule. Now we can add and subtract negative numbers. So first situation. If the numbers have the same sign. So we have two positives and two negatives. So this is what we'll do. Let's say we have negative 3 plus negative 2. Now what we always do is we convert everything into a plus. I'll do another example where we have to do this. So if they're the same sign, negative 3 plus a negative 2, we add together the positive versions of these numbers. So 3 plus 2 is 5. And then finally, the common sign attached to these numbers, we attach to the answer. And that's going to be our answer. Questions about that? Let me do another one. Negative 10 minus 2. When we're working with negatives, convert this to a plus a negative. So this will become negative 10 plus negative 2. These have the same sign. So first off, we add the positive versions. We get a preliminary answer. And then we take these common signs and we attach it to the preliminary answer. And that gives us our answer. Now, that's if they have the same sign. What if they have different signs? So let's say we have this. -3 plus 2. Well, first off, what we do is we take the positive versions of these numbers. Now this one's already positive, so we don't have to do too much work here. But then once we come up with the positive versions, we subtract the smaller positive from the bigger positive. And then we attach the sign. We look at the two numbers. We have a +3. In fact, let me try a different approach to this. I want to put in an extra step. We make everything positive. And then we subtract the smaller positive from the bigger. And so we have a preliminary answer. We're going to make a note that this is bigger. So for the third step, we take a look at this bigger number, which is 3. Three is bigger and it had a negative. So what we're going to do is the bigger positive number, whatever sign it originally showed up with, that will become the sign of our answer. So 1 will become -1. And that's going to be our answer. Let me do more of this. Two minus 10. We can write this is 2 plus -10. So first off, these are different signs. This is a positive, this is a negative. So the 2 stays positive. The -10 becomes 10. And this one's bigger. So we subtract the smaller from the bigger. And since 10 is bigger, we look at the sign that 10 had. 10 had a negative. So that means our answer is going to be negative. So 8 becomes -8. Let me do another one. -3 plus 7. Well, we have different signs. We don't need to convert any subtractions to addition. So first off, -3 becomes 3. 7 remains 7. And 7's bigger, so I'm just going to circle it. That's your bigger number. We subtract the smaller positive from the bigger. And that gives us our preliminary answer. Now 7 is bigger. That's our bigger positive. And it showed up positive. So since 7 showed up as positive, our answer is going to be positive. Questions about that? Let me do one more. Yikes. Well, we've got a double negative. And again, with double negatives, we can ignore the parentheses. At least in this case. There will be a situation where we don't want to ignore it. We'll get to that later. It has to do with PIMDOS. But in this case, there are no operations to be done in here. So we can now ignore the parentheses. Double negative becomes positive. And now we have different signs. So first off, negative 6 becomes 6. 30 stays 30. And 30 is the larger number. We do our subtraction with the positives. The preliminary answer. And then 30, once we simplified it down to this, in this case, 30 shows up positive. When we make this conversion, we get to here, we're going to be focusing on this right here. We can pretend that doesn't exist. So in this, 30 showed up positive. So the bigger number, 30, was positive. So 30 stays the same. And that's going to be your answer. So we went a little bit over today. That's all right. We had some things with the registration we had to sort out, and all that happens. So this will carry you into section 1.2. The things in 1.2 we still need to cover, it's PIMDOS and some square roots. And then it looks like distribution. And then that'll finish up section 1.2. So I'm going to adjust the due dates for the homework. So you can, well, we'll save 1.2 so it's not due till Thursday for sure. 1.1 will be due on Tuesday, but 1.2 will skip it ahead till Thursday, and then I'll move 1.3 and 1.4 most likely. And that's it. So hopefully we're getting everyone on board with the registration. You do have, with the temporary access, you can get to the class. And I'll talk to Pearson and try to figure out how to do the permanent access. You can try to talk with them through the chat system and try to figure out what's wrong. The way to talk to them would be to sit down in front of your computer, chat with them there, and explain to them everything that you've done, that you have the temporary access. You might need to give them your activation code and ask them, what can you do to get this activation code to work? They might be able to pull you in, or what they might do is refer you to the bookstore. And so you'd have to call the campus bookstore, and they should be able to come up with another activation code for you. If none of that's working, get a hold of me, send me a message, and then I'll see what I can do. I'm going to try to see what I can do anyway, but get a hold of me and we'll try to figure this out. But that's it. Hope you're having a wonderful week. Enjoy your weekend. Any questions, let me know. I'm going to be catching up on messages this afternoon. And other than that, have a great day.